Hello, this video will be a review for our first test over radicals and exponents in Algebra 1 at Shadow Creek High School. For my students, you can see this week we're going to have some Google Classroom assignments. We will be doing these for warm-ups this week. Just added those today, as well as our posting for this week. This video will go here. WIP, WIP, that means work in progress. And here's all our links for this week. And here is the review. In case you lose your paper copy, you can print another one. So our review for the test, we've got some, in this first section, we've got some radical form and some exponential form, and it says match each radical expression with its simplified form. So if we just start from the top here, we've got 10m to the 1/2. And if we pull this off to the side, so this 1/2 is only being applied to the m in this case. So our 10 is going to be out to the left, and then we're going to multiply that. And we don't have to put this multiplication dot, but I'm putting it just so that we're clear. And then we'll have our radical sign, and our base will go in here. And the numerator, the top number of that fraction, that is the exponent on our base. And then the denominator, the bottom number on our fraction, that's which root we're taking. So that goes over here. And so normally you would just see this as 10 radical m. If you don't see an exponent, it's assumed to be a 1. If you don't see a number to the left of the radical sign, it's assumed to be a 2. And so we see that here with number 4. So we put that there. So if you haven't already, try to finish the rest of these on your own. Go ahead and pause the video and then use the video to check your work afterwards. All right, so hopefully you've taken a look at that. Moving on to the next one, we've got something that looks very similar, 10m to the 1/2. This one is 10m, and then all of that in parentheses, and then the parentheses to the 1/2, not just the m. So in this case, it's going to be everything in the parentheses to the 1/2. So we'll have 10 to the 1/2 and m to the 1/2, which we can write with our radical 2 and m. And if we don't see an exponent, it's really there. We just don't write it when it's a 1. Just like we don't write the 2 usually on a radical if we're just taking square root. So normally you would see this written as radical 10m, which we can see here on number 2. Okay. This arrow here. Okay. All right, so our next one, we've got this radical 400m. So for this one, it's already in radical form. So we know there should be a 2 here because we don't see a number, which means we want to take the square root. And so since we're already in radical form, we can switch this to exponential form. And we would do that by applying the square root to each of the terms on the inside. So 400 square root of 100, or 400 to the 1/2 times m to the 1/2. Okay. And then 400 to the 1/2, the square root of 400, that's going to be 20. And we see right here, we've got a 20 in an answer, and then it's in radical form from there. And so we could rewrite our m to the 1/2 as the square root of m. To the half power means the square root. That's C right there. Okay. And then this last one should be D, but let's just double check and verify, just in case we made any errors in our other work. So 100 m to the third to the 1/2. The parentheses are going to the 1/2 power. Remember, if you don't see an exponent, it's really there. It's just a 1. And so power to a power, we need to multiply. So 1 times 1/2, that will give us to the 1/2. So we're going to have 100 to the 1/2 power, or the square root of 100, times m. But now instead of 1/2, it's going to be 3 times 1/2. So that's going to be 3 halves. Now 100 to the 1/2, that's just the square root of 100, so that's going to be 10. Actually, I'm going to give us a little bit of space here. I'll do this one in a little bit more detail. So now m to the 3 halves, that's the same as saying the square root, because our denominator is 2, that goes here to the left of the radical, times m to the third power, and then the square root of that. Remember that an exponent tells us how many times we're going to multiply the base together. So we can rewrite this as 10 times the square root of m times m times m. And if we collect these two m's, we're going to get m squared times m. And of course, this is still the square root. And now the square root of m squared, that's just m to the 2 over 2, which is m to the first power. So we can actually pull this m out, and we're going to wind up with 10m. And then we still have that last m remaining on the inside. So the square root of one more m. And that is indeed what we see here with number 3. Okay. So that wraps up this first section here. I'm going to pause the video and clear the screen. Alright. The next section, it says simplify all of that completely, reduce all fractions, and do not leave any negative exponents in your answer. So we're going to have 25 to the f, or times f to the negative 2, times g squared, all of that divided by 5f, so first power, times g to the negative 3. So this looks a little bit hairy, but hopefully you can remember from class, or you've checked your notes, or even checked your STAR reference sheet for how to handle negative exponents. And essentially with a negative exponent, we can flip it to the opposite top or bottom and then change the sign. So our 25, that stays the same. And we can actually flip the f down and leave the g here, g squared. Okay, so 25 times g squared. And all of that's going to be over 5. We still have our f to the first power. Now we're going to, so our f to the negative power, we can, actually I'm going to go the other way. We can bring that down to the bottom, so times f to the positive 2. So when we move it to the bottom, we're going to switch the sign. And then we can do the same thing with this g here. And we can bring that up top. So times g to the third power. And actually, I'm going to show you why this works here in just a second. But now we can simplify. We get 25 divided by 5. That's just going to be 5. Okay, so simplify, divide the top and the bottom by 5. And whenever we multiply same bases with an exponent, we're going to add our exponents. So we're going to get 5g to the 2 plus 3. And all of this is going to be over 1 times all of this, so we can leave the 1 out. So we're going to have f to the 1 plus 2. So then we'll wind up with 5g to the 5th divided by f to the 3rd. All right. So explaining it a little bit more clearly why this works, I'm actually going to drop out the units and just focus on the f's and g's. So to start, we've got f to the negative 2 times g to the 3rd, or sorry, to the 2nd power. And then all of that's divided by f to the 1st power times g to the negative 3. So if we want to get rid of the negative exponents, we know that this f needs to move down to the bottom, but how does it actually move down there? And if we think about, actually I didn't mean to connect that. If we think about our exponent rules, we know that if we multiply the same base, then we can add the exponent. So if we multiply by the opposite exponent of that base, so instead of f to the negative 2, we multiply by f to the 2, that gets rid of it up top. But of course, that would change what this is unless we also multiply by f to the positive 2 on the bottom as well. So anything divided by itself here is going to be 1, except 0. So we're multiplying by 1. That doesn't change it. But now we wind up in this case where we have f to the negative 2 plus 2, which is 0. And anything to the 0th power is going to be 1. So this cancels out here. And so on the bottom, we're going to have our f to the 1 plus 2. And then for our g's, it's the same thing. So we've got this g to the 3rd power, to the negative 3rd power, rather. So if we multiply by the positive 3 power, then we'll wind up with g to the negative 3 plus 3. Anything plus its opposite is going to be 0. And anything to the 0th power is going to be 1. So then this cancels out. But again, we want to multiply by a total of 1 so that we don't change the answer. And so now we've got our g to the 3rd power up top. So we'll have g to the 2 plus 3 power. So we multiplied by 1 here and 1 here, in essence. And we were able to switch our negative exponents either from the top to the bottom for the f's or from the bottom to the top with the g's. All right. I'm going to pause the video and clear the screen again. All right. For 6, this is going to be an extension of applying our power to a power rules and our product and quotient rules. So this 3 we'll need to distribute to everything in here. So we'll have 3bn, and really what we're doing is we're taking 3 of these 3bn's and multiplying them together. That's what this exponent is saying, is to take 3 of these and multiply them together. You take this base this many times, the exponent number of times, and multiply them together. So 3 times 3 times 3, that's going to give us 27. B times B times B is B to the 3rd power. And n times n times n is n to the 3rd power. So that's this part. And then the next part, we need to take 2 of these -4 b to the 2.5 n to the 1/2 and multiply those together. And so a -4 times a -4, that's going to give us a positive 16. And b to the 2.5 to the 2, remember that when you have a to the m to the n, that really means a to the m times n. So 2.5 times 2, that's going to give us 5, so b to the 5th power. And n to the 1/2 times 2, that's going to be n to the 1. And so now we can multiply these two terms, and we'll have 27 times 16, and this will be 270, 120, 162, so that'll be 432. And we've got b to the 3rd and b to the 5th. Multiplying the same base, we add the exponents. So we'll get b to the 8th, and n to the 3rd times n to the 1. That's going to give us n to the 4th power. Okay. In this next one, we just need to fill in the blanks to correctly simplify the following expression. At this time, I'm going to encourage you to attempt to solve this on your own if you haven't already. Encourage you to pause the video and try it out, and then use the video to check your answer. All right. So we've got 4t to the 1/3 times 3.5t to the 2.7. We're multiplying these together. So that's going to give us, let me do a new color here. 4 times 3.5, that's going to be 14, which we see here. And t to the 1/3 times t to the 2.7, that's going to be t to the 1.3 plus 2.7. When you have the same base and you're multiplying, then you add the exponents. 1.3 plus 2.7, that would give us 4 here, so that's our first blank to fill in. And then that's all divided by this section right here, 2 times 7 to the t, or 2 times 7 times t to the 4th. So for this one, we need to do the 2 times 7, which is going to be 14. Okay. And then we need to fill in 2 blanks on this next part. 14 divided by 14, that's just going to be 1. And then t to the fourth divided by t to the fourth, when we're dividing with the same base, we subtract the exponents. So we're going to have t to the 4 minus 4, which that means this will be 0, t to the 0th power. And then anything to the 0th power is 1. So this is t to the 0th times 1, or equals 1 rather. So we're going to have 1 times 1, which is just 1. Alright, going to pause the video and clear the screen again. Alright. Number 8. What is the value of the variable m so the whole expression is equal to 1? And explain your answer. So this one looks kind of tricky, but if you remember your exponent rules, it should pop out to you. So hopefully you thought about that a little bit. So we've got this set of parentheses right here. And this set of parentheses is being raised to the exponent m. And we're getting 1. And so what exponent can you raise something to and always get 1? If you have a base of 1, you can raise that to any power. You can raise that to 0, 1, 2, 300 million, because it's always going to be 1. But we don't know if that's what is in here in the parentheses. But there's one value we can stick in this m, and it doesn't matter what these x's are or what these y's are, and it will always equal 1. And that is 0. Anything to the 0th power is going to be 1. Okay? So if we were to assume that all of this is 1, then m could be anything. But we can't make that assumption. We don't know for sure. But we do know for sure that if m is 0, then it doesn't matter what's inside the parentheses, because it'll be 1. Okay. Now 9, which number goes in the blank rectangle to make these two expressions equal? So we are multiplying same base times same base and getting same base. So that means we need to add our exponents. But in this case, if we have 2 plus 2.5, that's not going to equal 7. So we need to put some power here to raise this second b up. So there's a few ways we can do this. And one way is basically we want to get 2 plus 2.5 times something. Okay. And we can put a box, or you can put an x, whatever you're most comfortable with. And this is going to equal 7. Okay. So if we subtract 2 from both sides, we know that we need to get to 5. And we're multiplying by 2.5 here, so if we divide by 2.5 on each side, then we get that our variable should be equal to 2. So b to the 2.5 power to the second power, we would multiply 2 times 2.5, we'd get 5. And then 5 plus 2 would give us 7. All right, number 10. Give an example of each of these. So natural number, you could, 1, 2, 3, 4, 5, 6, 7, 8, 9, 100 million. No zeros, no negative numbers. Okay. The fraction, well, no fractions that don't simplify to one of the natural numbers. So you can put 1. Whole number. So whole numbers are all of the natural numbers and 0. So 0 is a nice one to put there. Integers, this is where we start including negatives. So let's put maybe a -7. Rational number is anything that can be represented by a fraction. Okay, so let's do, I don't know, let's do negative 23%. Okay, and then irrational number, this would be your pi, phi, Euler's number, okay, all of those things. All of your numbers that cannot be represented as a fraction. Number 11. Priya, Cameron, and Aaliyah are trying to simplify the expression 1/2 times 7 plus negative 5. Both of their, or I should say all of their first steps are listed below. Who is correct, and explain, and did anybody make a mistake? And explain why their response is wrong. So let's look at these. Priya, well, first of all, they all have 1/2 times 7 plus negative 5. So nobody wrote it down wrong. And it looks like Priya, she distributed the 1/2 into the parentheses. So 1/2 of 7, that is 3.5. And 1/2 of negative 5, that is negative 2.5. So Priya is correct. Okay. And it's hard to write with a mouse, so I'm just going to put P. And Aaliyah, she put 1/2 of, she did the same process. She distributed the 1/2 into the parentheses. So 1/2 of 7, that is 3.5. And then 1/2 of negative 5, she said, is positive 2.5. Well, that's not correct. Half of negative 5 is going to be negative 2.5. So Aaliyah made a mistake. Okay. And then Cameron, it looks like he didn't distribute first, he actually did the parentheses first. So he's doing strictly order of operations, and this method can work as well. And he said that 7 plus negative 5 is positive 2. So there's a handy little rhyme that you may have heard of. Same signs add and keep, different signs subtract. Keep the sign of the one you have more of, then you'll be exact. So 7 and negative 5, these are opposite signs, so we would subtract. 7 minus 5 is 2. And then we would keep the sign of the one we have more of. We have more positives than negatives. So it would be positive 2. Okay. You could also see this with tiles. Say, for example, if you have a positive 5 and a positive 1, 2. So this is 7 positives, and then plus 5 negatives. So negative 5. 5 and negative 5, these would cancel out, and what would you be left with? 2 positives. Okay. And then he's kept the 1/2 there, and he'll take care of that on the second step, it seems like. So Priya and Cameron are correct. Priya, because she correctly distributed the 1/2 into the parentheses, and Cameron, because he correctly processed within the parentheses. And then Aaliyah made a mistake because she dropped her negative sign when she took the 1/2 of negative 5. All right. Number 12. Simplify completely. Negative 2 minus negative 3 plus 5 divided by 2 over 1 times negative 3. So negative 2, so if we follow order of operations, parentheses, exponents, multiplication and division from left to right, and addition and subtraction from left to right, then we'll have negative 2 minus negative 3 first. And if you're subtracting a negative, if you're getting rid of a negative, that's actually a good thing or a positive thing. So you can change it to plus plus, or perhaps you're familiar with keep, change, flip to change your subtraction problems into addition problems. Okay, so the first number stays the same. We change the addition to the subtraction. We change subtraction to addition. And then we take the opposite of the second term. So the opposite of -3 is +3. Or we could also think about if we have two negatives and we want to take away 3 negatives, we don't have 3 negatives to take away. So if we add another negative and a positive, so right here, if we add this, a negative and a positive, that's 0. So if we add 0, we didn't actually change it. This just helps us visualize it with tiles. So -2 plus 0 is still -2. We didn't change that. But now we have 3 negatives that we can take away. And what do we have left? We've got +1. So right here, this is going to be 1 plus 5. So that's going to give us 6. And then 2 over 1, that's just another way to say 2. So we're going to divide by 2 and times -3. Now, very important. If you think that multiplication comes before division, you're going to do this 2 times -3 first, and you're going to get -6, and then you're going to get 6 divided by -6 is -1. However, that is not the correct answer. Multiplication and division have to be processed at the same time from left to right. So multiplication is not the first operation we see, it's division. So we're going to wind up with 6 divided by 2 is 3 times -3, and then we will wind up with -9. Okay. And 3 times -3, that's like having 1, 2, 3 -3s. So 3 times we have 3 negatives. So 3, 6, 9 negatives. Okay. And 13, we've got the absolute value of -7 plus 3 minus 4. And so for this one, I'd like to show you this one on a number line. So if we have 0, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 9, 8. So here's -7. So we start here on -7. If we add 3, that means we need to go 1, 2, 3 to the right. So it'll be right here. And actually, let me do different colors for this movement here. So we're going to 1, 2, 3 to the right. And then -4, we're going to go 4 to the left. So 1, 2, 3, 4. We'll wind up here at -8. So we're going to wind up with the absolute value of -8. Okay. And absolute value is, it's not always positive, but it is never negative. Okay. All it is the distance from 0. So if we go from 0 and we count to -8, we go 1, 2, 3, 4, 5, 6, 7, 8. We just count how many spaces it is. We don't care which direction it is. Just how many spaces away from 0. Okay. And 14, this one's actually fairly similar to other problems we've done already, so I'm going to encourage you to pause the video and solve it on your own if you haven't already, and then use the video to check your work. Okay, so hopefully you've taken a look at 14. So for this, we're going to have 3 times 4 will give us 12. And z to the fourth times z to the second should give us z to the sixth. We have the same base with those z's, so we can add our exponents. 4 plus 2 gives us 6. Okay. And I'm going to pause the video and clear the screen here. Alright. Prime factorization to simplify the square root of 250. So prime factorization means we need to break this down into factors. Lots of different ways we could do that. It ends in a 0, 2, 4, 6, or 8, so it's even, so we could divide by 2. Also ends in 0 with other stuff to the left, so we can divide by 10. So actually, let's go ahead and do that. We'll do 10 and 25. And 25 would break down into 5 times 5. And 10, we could break that down into 5 times 2. So prime factorization is going to be this business here. And we need the square root of all of this. Well, right here we've got 5 times 5. That's 5 squared. So the square root of 5 squared, that's just going to be 5. But then over here, we don't have a second power. So we're going to have something in the radical. And we probably don't want to put 2 times 5, so we would put times 10. So 5 times the square root of 10. Okay. And 16. This one's very similar to the one we've already done, so I encourage you to pause the video and try it on your own if you haven't, and use the video to check your work. Okay, so hopefully you've taken a look at number 16. And so 49 divided by 7, that's going to give us 7. And our larger negative exponent value is going to be on the top, so we're going to move that down to the bottom. And when we do that, it's going to change to a positive 8. So we'll have p to the positive 8. Okay, and that's going to be times this p to the negative 2, so we'll have minus 2. And so we'll wind up with 7 over p raised to the 6th power. And to show this a little bit more clearly, we'd have, actually I'll just show it with the p's. So we would have 1, 2, 3, 4, 5, 6, 7, 8 p's on the bottom. So remember, we moved those to the bottom to keep them positive. And then we moved the negative 2 p's on, or p to the negative 2 power rather, to the top. So we would have 2 p's on top. Okay. And then p divided by p, that's 1, cancels out. P divided by p is 1, so that cancels out. So then we're just left with our 7 over 1, 2, 3, 4, 5, 6 p's multiplied together is p to the 6th power. Okay. And then for 17, we've got 4 to the 5th power times 4 to some power gives us 1 over 4 to the 3rd power. Again, using our negative exponents, we can flip this 4 to the 3rd power up top. And so we would have 4 to the 5th times 4 to the, we don't know, we can put an x, equals 4 to the negative 3. And since these are all the same bases, and on the left side we're multiplying them together, we know that 5 plus x equals -3. And the opposite of adding this 5 is to subtract 5. So we'll have x equals -3 minus 5. Break up the number line again to show you all this. So we've got -3, -4, -5, -6, -7, -8. If we move 5 more times to the left, subtract 5, we get -8. So this number here should go right there. Okay. Clear the screen a little bit. And on to the last problems. All right. So 18 says if volume equals length times width times height, write an expression to represent the volume and simplify completely. So for this, we're just multiplying these three things together. So we're going to get 4x to the third times 3x to the second times x to the third. And remember that if you don't see a coefficient, it's assumed to have a 1. So we're going to have 4 times 3 is 12 times 1 is 12. And then our x, we've got the same base on all of these, and we're multiplying, so that means we can add our exponents. So we'll have x to the 3 plus 2 plus 3 power, which will give us 12x to the 8th power. 19. Taylor and JT attempted to correctly simplify an expression. Identify who simplified it correctly and explain why. So on this one, the language seems to suggest that one is correct and one is not. So if we look at Taylor's here, we see 7.2 divided by 2.3, 7.2 divided by 2.3, and then, right, let's see, we see a 4 right here. Okay, so 7.2 divided by 2.3, well, if we think about it, 2 times 4 would be 8. So that's already a mistake. Okay, then let's see what else is going on here. We've got 10 to the -3, and it looks like 10 to the -2 on the bottom, and then it looks like she brought that up to the top, but then she didn't change the sign there. And really, if we want to get rid of the negative exponents, we should have moved the 3 down to the bottom instead. Okay, and then it also looks like, see, -3, 10 to the -3 times 10 to the -2, even if that was correct, we would add these exponents and we would get -5, not +6. So she must have multiplied the exponents. -3 times -2 is 6, but that's not what you would do if you were actually multiplying those two terms. So Taylor is definitely incorrect, and there's those three reasons why, so you can explain those. And then let's look at JT. JT looks like let's change colors here. Looks like he moved that 10 to the third power, or 10 to the -3 power rather, down to the bottom, so that's good. And then he's got 3 minus 2, so if we have 10 to the -3 on top, when we move it to the bottom, it's going to be to the +3. So that's great. And then 10 to the 3 minus 2, that would be 10 to the first power. And 2.3 times 10 should be decimal right here. 2.3 times 10, that would give us 23. And then so he winds up with 7.2 divided by 23. So JT is indeed correct. I'm not sure if that's a he or she, but they got it right. And in this case, Taylor did not. And then number 20, simplify c to the 1.25 times 4. And again, when we have a power to a power, we multiply. So we're going to have c to the 1.25 times 4. And 1.25 times 4 is going to give us c to the 5th power. All right, that wraps up this video. Hopefully it was helpful. Of course, you can not rewind, but go back to any parts you want to look at some more, or you can check out various resources on Khan Academy to help you out. Go to tutoring. Lots of options available. Good luck.